Hey guys, now we will see how STP generates in layer 2 switching network. STP means spanning tree protocol that works in layer 2 network. Let's get started. So packet tracer, click on switches here, then you will see these all are switches. Take any one, click here, then click here, click here, click here, and do the connectivity between these switches. We'll do redundant connectivity. Click this is the connections. Click here, you will see all the cabling type. So we will see here straight through crossover. So between switch to switch, mainly in packet tracer, we'll take crossover cable. So STP normally by default will be enabled when we'll connect redundant links between two switches. So we connected two links between these two switches. So STP will be enabled by default here. No need to do extra configuration for STP enabling. And between these two, one switch will be root and one switch will be non-root switch. And all the ports on root switch will be into designated forwarding mode. And on non-root switch, one will be root port and one will be blocking or alternate blocking ports. Now we'll discuss that how these elections happening means STP elections, how root port selection is happening, we'll see step by step. So if STP is not there, then what will happen? Open paint, then this is a switch like, so this is one more switch, take host, host, then connect here parallel, parallel, then connect host also, host also. So if STP is not there, so there won't be any block port. All the ports will forward or receive traffic here also. So what will happen if this host send traffic here for first time and the switch database is not updated with the source and destination MAC address? So in this case, this host send a packet here to this port, but the switch doesn't have the destination MAC address to their database, then the switch will forward or broadcast that packet to all the connected switching port like except this port. So like the packet will come through here, come via this link and will come here. But this switch also doesn't have the destination MAC address. Again, this switch will do the broadcast and that packet will go over all the connected links like it will going this link, but whatever traffic coming via this link here won't send back. That traffic will come like this, and from this whatever coming via this link won't go back. It will come here and go there like this. And again the packet will come here. Again this switch will do the broadcast same way. Again it will come here, and like this it will coming here, and it will create a switching loop like this. It will like with this roaming between the two switches, two ports. It will roaming like this. it will generate switching loop, then multicast storm, then broadcast storm. Your network will be isolated. You won't be able to access any network. So that's why STP came into picture. One port will be blocking on non-root switch. Now see how STP selection happens and how root port selection happens, how non-root or blocking port selection happens. So when connect two switches with redundant link, there will be one elections that will be STP elections. Open this CLI, enter, enable, show spanning tree. So we can see here this bridge is the root bridge. So switch 1, sorry, this one switch 1 is the root bridge, and see all the ports connected here is designated forwarding. Let's see here. CLI, enter, enable, show spanning tree. We can see this port is the root forwarding port, and this one is blocking or alternate blocking ports. So now we'll check why this switch is root switch and why this switch is non-root switch, why this port is root port, why this port is blocking port. So when two switches or multiple switches connected through maybe two switches or multiple switches, maybe 3, 4, 5, 6. If you go for larger network, you will see multiple switches. So connected through redundant link, there will a STP election occur, and one switch will be elected as root switch and other will be elected as non-root switch. So what is the criteria to become the root switch or root bridge? Bridge ID. That is called bridge ID. So bridge ID consists of switch priority and MAC address. So first they will check the switch priority. The switch having the lowest priority will be elected as the root bridge. So here we can see priority, same priority. Then the next criteria is MAC address. So MAC address, we can see MAC address for this. This is the MAC address 0040, yeah, 00E, then B, then C. So if you see, so this MAC address is the higher MAC address, this is the lower MAC address. So the lower MAC address switches will be elected as the root bridge. So this switch is the root bridge. And default switch priority 32768, and with that the VLAN number will be added. That means here VLAN 1, that's why it's showing here. If VLAN 2, you will see different number. Okay, now this is the root bridge. Now we'll see here why this is the root port, this is the non-root port. So all the non-root switch, so there will be cost for the link towards the root. So the switch, the port having the lowest cost, that port will be the root port. So here we can see both the cost is 19. Then why this is blocking and this is root. So next criteria is port priority or port number, lowest port number, or we can say priority C. This is the number 1, this is the port number 2. So that is the lowest port number or port priority, that is the higher. So that's why this is the root port, this is the blocking ports. So if you connect one more link, see what will happen. You can connect, doesn't matter. So here will be designated forwarding, where this port will go into blocking, alternate route. So we'll check in the CLI also. See here, we can see here designated forwarding because this is the root switch. Check on non-root switch. See here alternate blocking. So only one will be root, other ports will be go into alternate blocking. Thanks for watching. We will see more STP features in the next video. Bye bye.